All right, we got one more thing to do here. Um, we're going to do learn and target C here, which is I can model with absolute value functions. Our goal is to take some sort of real life situation, which we're going to do this problem example 3 down here, and I'll flesh it out for you and model it with an absolute value. A lot of times pool tables deal with absolute value equations. And if you read this, I'm just going to cut to the gist of things. Anytime there's a reflection, all right, you have the angle of incidence, which is the angle that your object, your reflective object, is struck at, and your angle of reflection. And these angles match, all right? And we got an example down here that's going to show the same thing. So I'm going to read it to you, even though I know you have the ability to read. At a science museum exhibit, a beam of light originates at a point 10 feet off the floor. So it looks like the beam of light originates here. It is reflected off a mirror on the floor that is 15 feet from the wall the light originates from. Okay, how high off the floor on the opposite side does it hit if it's 8.5 feet? So the goal is for you to understand that this angle here and this angle here are the exact same. So that means basically that this is symmetrical around a line drawn down the center, and we can kind of see that it's absolute value. I will draw that line. So the same slope here towards the mirror on the ground is over here. Obviously that's an opposite slope, which is what absolute value equations create there. So let's go ahead and study this. We're going to identify some points. The mirror is on the ground, so we know our K has not moved up, it's 0. The mirror is 15 feet to the right, so our H happens to be 15, all right? And we're going to leave B as 1, and let's go ahead and think about A as, you know what, how far this is stretched. So we used to write this separately as B and A, but if we think about it, this is a vertical shrink, or vertical compression of 10 over 15, which if we reduce that, it's a vertical compression of 2/3. All right. So if I write this, and here we go, we're going to write g of x equals 2/3, which we reduce from 10/15s, and if you kept that as 10/15, that's okay, times the absolute value of x minus 15. Remember, counterintuitive, it does move 15 right. And honestly, that's it. There's no k. This should be our equation. All right. So here we go. We are going to write that equation here. So write an absolute value function. Here we go. G of x equals 2/3, and then I've got x minus 15. All right. And now we're going to find out how far it is. So we're going to have to figure out a portion and plug in. And our inputs have to be the distance along the bottom. It looks like from this point, right, this is the origin, 0, 0 right there. Let the base of the first wall be the origin, so 0, 0 if you notice that. Our input to find out the height is going to be the sum of both these, because if I plug in 15, I'll get 0. But I need to plug in the entire distance from the wall to get this height. And that's just 15 plus 8.5, so your x equals 23.5. And we're going to go ahead and solve this. So if I plug that in, I'll say g of 23.5 is equal to 2/3, the absolute value of 23, no, I wrote that backwards, 23.5 minus 15, which gives me 2/3 times the absolute value of, well, 23.5 minus 15 is 8.5. All right, so g of 23.5 is equal to 8.5. Well, you know what? I'll just do this real quick. 8.5 times 2 gives me 10, 17. So we got 17 divided by 3, and I'm just going to leave that as 17 over 3, and we can say approximately was that 5 2/3, so 5.67. And what are we talking about, feet? And there we have it. All right. Does it make sense? Well, this says justify and evaluate. Does this thing make sense? Well, if we look over here, 10 feet off the ground, I'm not traveling as far. So this is about 5 2/3. There's a lot of ways. I mean, it makes sense to justify and evaluate. We plugged it in. We could plug it in backwards, so let's see if it works out that way. All right, let's see if we plug in 5.67 over here. So we'll say 17 thirds is equal to 2/3 times x minus 15. And we'll see if we plug it in backwards, if we'll actually get the x value of about 8.5. So we multiply both sides by 3/2. Let me make it so you can see. By 3/2, and I get 17 halves equals x minus 15. 17 halves is about 8.5 equals x minus 15. And sure enough, if I plug in the y value, I get an x value of 23.5, and we have checked this forward and backwards. So there is the rest of these notes. You should be ready to work tomorrow in class, and I will talk to you soon.